Today we're going to take a look at the Cartesian coordinate system. In particular, we're going to talk about graphs and, again, in particular, graphs of lines. To start with, I'm going to talk a little bit about one observation about graphing of lines that is true. Since every 2 points lie on exactly one line, it's actually only necessary to plot 2 points and connect them to create a line, at least the visual representation of a line. So as we're looking at graphing today, that's going to be the approach that we're looking at, and we'll approach things from a different perspective later on. But for today, really all we're going to do is find 2 points and to connect them to create our line. So our first example is y equals negative 2x, and as we look at these, what we're going to do is we're going to create just a small table. So an x and a y, and you can either choose values for x and find y, or values for y and find x. But choose nice stuff, right? So like x to 0, that's a very nice thing to choose. And if I plug 0 into this equation, then y is also 0. And maybe you choose x is 1. So if x is equal to 1, you have negative 2 times 1, so your y value is negative 2. And we're going to come down and we're going to plot that. So there's 0, 0, and then I have 1, negative 2, which would be right here. And we're going to connect those two with a line. That looks relatively decent. Lines have arrows on the end, so we'll tidy that up. All right, let's try another one. This one has a little more going on than the last one did. Again, I kind of like letting x is equal to 0 unless there's a reason not to, maybe. On this one, of course, that 0 is out this part of it, but then I have a 2 left, so y is 2. And then we can choose anything else again that we like. I'm going to choose x is equal to 1 again, just because I can. So 3 times 1 plus 2. So that's negative 3 plus 2 for a total of a negative 1. And we're going to plot. So 0, 2, and 1, negative 1. And we'll connect them with a line. That's reasonably good. Sometimes it's a little tricky to get things to line up very well, but make sure when you're making your lines that you're doing your very best to be straight. Make it realistically look like a line. I'm not going to make you get out a ruler or anything, but do try to make it straight looking. All right, another one. Here's one that's got a fraction involved. Okay, so I've got 4/3 x plus 1. So again, x is equal to 1 is nice and y is 0, or x is equal to 0 is nice and y is 1. On this one, it's not really especially nice to let x equal to 1, because then I'm going to have to add 4/3 and 1 together. But if I let x equal to 3, it is nice, because 3 would cancel the denominator of 4/3, leaving with 4 plus the 1 at the end, so we've got 5. So that's actually a pretty nice one to plot. So 0, 1 would be here, and then 3, 5 would be here. And then we're going to connect them. Okay, and there's that one. Here's in the end. And we're good to go. Number 4 is written in a different form. This is actually called standard form, or sometimes they'll say general form, usually standard form of a line. And as we do this one, sometimes it feels a little bit different. We're going to do it the same way. In particular, on this one, it's not especially nice to let x equal 0. And the reason it's not is because, let's say you didn't have this piece here, and then you're going to have to divide this by 4. So your y value actually ends up being 1/2. So not that, 1/2 is terribly awful, but it's not super friendly either. So instead of letting x equal to 0, we could let y equal 0, and that's actually pretty nice on this one. So if y equals 0 here, oops, there we go, then this piece goes away, and so I'm left with x equal to 2. So that's a pretty nice value for that one. You could also let y equal, say, negative 1, or 1 if you prefer, whatever you like. And so if y is equal to negative 1, then we'd have 4 times negative 1, like this. So you'd have negative 4. So x minus 4 is equal to 2, and then you can add the 4 to both sides. So you'd end up getting, x is 6. So there's nothing special about which points you pick. You just need to make sure they work, of course, but you're going to have different points, at least potentially, than anyone else. So we're going to plot 2, 0. That would be here. And 6, 1. 6, negative 1, I mean, which would be here. And we will connect our dots. I'll move my line down to meet them at that point. There we go. So we have this. All right, number 5 and number 6 are interesting. We'll do it the same way. So on this one in particular, if x is equal to 2, which it is because it says so, right? The y actually can equal anything. So 2, 0 would be a point, and so would 2, 6, or 2, 8, or 2, 2, or 2, negative 5. So we're going to plot any of those. So 2, 0 would be here, and then my other one was 2, 6, and that would be here. And then when you connect them, in particular, you have what kind of line? The vertical line. And that actually always happens when you are working with x equals a constant, x equals a number. So this is a note I want to write down here at the bottom. All lines x equals a number are vertical. And then over here on this one, we've got a similar thing going on, except that it's the y value that never changes, right? Y is 2, and x can be anything. So maybe we have negative 2, and y is 2, and we have positive 2. I don't know why I'm in 2's on that one, but I am. So I have negative 2, 2, and I have positive 2, 2. And as we connect these with a line, you'll notice, of course, that this will end up giving us a horizontal line, right? And again, that always happens anytime we're dealing with an equation that is y equals a number. We always get a horizontal line. So we'll write a similar note down here at the bottom of this one. All lines that are y equals a number are horizontal. So those are kind of some unique lines. We're also going to take a look in this section at intercepts. So we've got two types of intercepts. We have an x-intercept and we have a y-intercept. The x-intercept is the location where the equation crosses the x-axis. And if you think about it visually, if you're crossing the x-axis, then it means the y, that is the distance up or down from the x-axis, is 0. So this is always y equals, I don't know why I wrote down y equals a number. That's bizarre. It's actually supposed to say y equals 0 here. And the location on the y-intercept is the location where an equation crosses the y-axis. So, oh, I know what I was writing. I'm sorry. I wanted to write two things here. I left one of them out. Okay, so where the equation crosses the x-axis, and if the equation crosses the x-axis, so this is supposed to say y equals 0. And the equation, which is what I wanted to write down for you, the equation for that is x equals a constant, a number, which is what we were seeing before. Is you're going to get x equals some number, and you're going to get y equals 0. So you're going to get some value for x, and you're going to get 0 for y. It's going to look something like that. For your y-intercept, it's the location where you cross the y-axis, so something like right here, right? So the x value, because you didn't go left or right any, is 0. So x equals 0. So again, this isn't an equation, but the point. Sorry, my slides are all messed up today, but that's all right. The point where it's crossing would be x equals 0, and there's a number in here for y, some value here for y. Okay. All right, so let's just try one. I have a graph here on the first one, and we're supposed to find the x-intercept and the y-intercept. So the y-intercept would be right here. And what you'll notice is that the y value at the y-intercept is 2. The x value there is 0. So 0, 2 is the y-intercept. And then the other one, the x-intercept, would be this location right here. So the x-intercept would be an x value of -2 and a y value of 0. And this is my x-intercept. We don't always have a lines graph that we're given. Sometimes we just have the equation that we're given. But in order to find the x-intercept, one of the things that I had written down on that previous slide is that it means that y equals 0. So if you take your equation and you plug in 0 for y, then you can solve for x. So of course this is 0, so I've got 3x equals 12. If I divide by 3, then x is equal to 4. So the x-intercept is x equals 4, y equals 0. And then if we do the y-intercept, again, we have to let x equals 0. So we have 3 times 0 minus 2y equals 12. So again, this piece is going to be 0, right? I've got -2y equals 12. And if I divide by -2, then I get y is -6. So the x value is 0 and the y value is -6 for that intercept. One more question. Occasionally we'll be given information where we're given the x and the y-intercept specifically, and then we're asked to graph the equation. So that's the case in this last one. We're going to graph the line, and they actually give us the intercepts, which is actually very friendly, and it's much like what we were doing earlier. It's just that we're specifically told the 2 points instead of having to find the 2 points, which makes it a little easier. So I'm going to draw this one out. So the x-intercept is -3. Okay, so that's where we're going to cross the x-axis. And the y-intercept is -2. So we're going to cross the y-axis right here. And then we're going to connect the two dots with a line. Just like that.